Hi, physics students. I'm Todd Burke. This is our physics class. So I'm going to have you track one day behind my regular students, and I will, in addition to having some video footage of directions, which is what this is, I can include some clips of students where I've got my phone out and I'm taking pictures or video over students' shoulders as they're doing the work, and you can kind of see what the lab looked like in the classroom. Sometimes that might help you. And but therefore, we didn't have something for you to work on the first day of school, and we'll always have a little bit of a delay that way. This first thing, I think this is backwards, and maybe I can find some editing software so I can flip it, but I think the way the camera mirrors work, what you're reading is illegible. What you see is written backwards. But this says in red, I can create a model and test it. It's what we're doing in class today. And in black above it is the standard. We will come back to you throughout the class where I have you engineer and build something complex, solving some strange or difficult challenge. So today's is pretty fun. It's based on a magic trick. What this says, if you can't read it, is the standard, and this is shortened. Design a solution to a complex problem based on trial and error. The full standard says something like based on evidence and research, et cetera, including trial and error. So today's challenge comes from a magic trick that I had when I was a kid. I have these two little magic wands. There's a little bit of a yellow tassel in each one. There's also a little bit of a red bead on one, and this is what they do. I'm going to hold it high so maybe with the white background you can see it, but there's a little bit of a string here. Can you see that? And if I pull the red bead on top, I can pull that string through the magic wand. So there's a little bit of a string here, and I can take this separate one here and pull it. This is kind of crazy, but I can shorten it by pulling the other wand. So, hopefully you can see that here. I can pull this red bead up. I can pull the yellow tassel down. And so all of this is connected. But I can also shorten it by pulling the yellow tassel on this other wand. So let's see if that works. Strange. So this is a magic trick I got when I was a little kid. Somehow I never lost it. I found that and kind of came up with this device. So here's some PVC. This is plastic plumbing pipe with end caps on it, and I've drilled holes, and I have this string right here. So you can see this string is attached. You can pull it all the way through. It's about exactly that long. And here's the interesting thing. If I then pull down over here, what do you think would happen? Now there's end caps here on the end so that you can't see how it works. If I pull down here, the string goes up there. Now I can pull this all the way through. And I can pull this straight through on this side, but I can also pull it diagonal. I can pull either the top or the bottom. And I can pull this back and forth, but I can control it diagonally as well by coming over here. So your task today is to build a model that performs like this white tube. What I've given students in classroom is just a little bag full of some common household objects. You can use different things. People in class solve this in many different ways. The basis is a little bit of toilet paper roll, but you could use paper towel roll, but you could also use some pipe. It could be metal, it could be plastic. So you need to have a tube. And then I have a couple kinds of string. I gave them several rubber bands. I put in some odds and ends like paper clip. You can see this is a clothespin from a clothesline, and I had a marble. That's a pretty distracting element there. I don't know how you'd use the marble. Here's a washer. Some of these bags had several washers. Students did a great job cleaning up and Seems like maybe some of the bags now have more washers and some have fewer. Here's a paper clip. I don't know what you call this, brad maybe, but you can put it through papers and separate it, and now it's like a staple and holds it together. I just got a bunch of random things together. And what I told students is get an idea, talk about it with someone, write it down, make a drawing, then make a picture. See if you can make your model. You want to create a model, test it, and see if does it actually perform like the white tube. So can you build something and then see if it performs the same way? Can you pull things straight across and have the rope come all the way through? And then can you control it by going to the diagonal side and pulling it across as well, so that as you pull up here, this one on the other side shortens? Can it perform exactly the same way as this tube? Now the white magic tube, again, does these things. I can pull this all the way through here, but I can pull that down again. I can control it also by pulling up here. I can pull it straight through, but I can pull this up on this side, or I could maybe pull it down and control it. So both strings have two ends. There's four ends, and when one is long, you can shorten it by pulling any of the other three ends of the string. So you'll build something and it may or may not work perfectly. Maybe it doesn't work at all. So then try a different idea. And then maybe it kind of works, but not in all ways. So maybe then you got a good start and prove it. What do you have to do to change it? Use trial and error until you can improve it, get it better and better till it performs like the white tube. That's your assignment. What I want you to turn in is a blueprint. So you can use graph paper, and you can just print this if you have access to a printer. You can buy some, but you can also just use regular paper. What I'd like is dimensions. Show me your tube. Tell me how long is it, how wide is it, and then show me what's happening inside. Then I'd like 4 or 5 sentence paragraph explaining how it works. What's important though, since this is virtual, is you then send me a video like I just made showing it work. Okay, I want a magic tube that works like my white tube. I'd like a blueprint and a 4 or 5 sentence explanation. Give me a video showing it work. This will be due in a week. I'm filming it on Tuesday. I'll probably get it published to you tonight. Sorry it wasn't available first thing this morning. However, yours will be due then next Tuesday morning. And I look forward to seeing him. Bye.